Welcome to week 7 in algebra. So we are going to start with a warm-up problem. So make sure you've got your math notebook out and you are ready to take notes. The first thing I'd like you to do in your math notebook is try out this warm-up problem. So remember, we've been looking at quadratic functions in Unit 6, and when we know that when we graph a quadratic function, we're going to get this U shape that we call a parabola. So the graph of a quadratic equation is called a parabola. And we've learned that we can solve for a quadratic function by finding the zeros when we look at the graph of a quadratic function. So I want you to take a look at this graph and find the zeros. So go ahead and click pause and try this in your math notebook, and then when you're ready to check your work with mine, go ahead and click play. All right, so to find the zeros, we want to look and see where our graph crosses the x-axis. So remember, the x-axis is your horizontal and your y-axis is that vertical axis. So where do we cross? We cross in two places, right here, and we can see that each of our boxes represents one unit. So right here would be at one of our zeros would be at x equals 1. And then we've got one more over here. And where is that one at? So one unit, we've got -5, and take one more away, so that would be x equals -6. So our two zeros are at x equals 1 and x equals 6. So let's move on and talk about what we are going to be doing this week. So this week, we are going to be covering 3 sessions. We are going to be continuing to explore different ways that we can solve for quadratic functions. The first way is factoring. So we learned back in Unit 5 how to factor. Now we're going to apply this to solving quadratic functions. Then we're going to move on to solving quadratic functions by using square roots. And then we are going to learn how to complete the square and how we can apply that to solving quadratic functions. So let's go ahead and get started and look at how we can solve quadratic functions by factoring. When we are trying to solve for quadratic functions, we always set our quadratic function equal to 0. And that's why on the previous slide I said that we're trying to find our zeros. So what is the solution that when we have a quadratic function is equal to 0? So when we set whatever our quadratic function is equal to 0, that's where we're trying to find those solutions for, is when the quadratic function is equal to 0, like x squared plus 4x minus 1. We're trying to find the solutions that make when the equation is equal to 0. And that's true with the graphing that we went over on the previous slide. That's why I said we're trying to find the zeros. So when we have a quadratic function that's set to 0, we're trying to find the solutions that make it just that. So if we are solving by using factoring, we're going to use the zero product property. And really what the zero product property is it's reminding us that when we have any number multiplied by 0, it's equal to 0, right? Because if we have 4 times 0, it's 0. If we have 6 times 0, you get the point. Any number times 0 is going to be equal to 0. And that's what this property really is stating. So if we have two terms, a times b, and we need it to be equal to 0, then either a or b can be 0, and we would get a product of 0, right? So either of our terms can be equal to 0, one or the other. And as long as one of our terms is equal to 0, then when we multiply the two terms together, it's going to be equal to 0. So we're gonna use that property to help us solve quadratic functions by factoring. So here I've got an example. It says solve. We've got x minus 5 times x minus 3 equals 0. And this is a quadratic function it's already been factored. But if we were to distribute, we would find this would be a quadratic function. So using the zero product property, as long as this term is equal to 0 or this set in this parenthesis is equal to 0. As long as either of those are equal to 0, then if we multiply them together, it's going to be equal to 0, right? So we're going to use that to help us solve this problem. So let me get rid of that now. I was just making sure we understand the zero product property. And now we're going to build off of that and solve here. So how do we solve this using the zero product property? Well, what we're going to do is we're going to set both of our sets of parentheses equal to 0 and solve for them. So I'm going to say, I'm going to say x minus 5 equals 0, and I'm going to solve for that. Or we've got x, minus 3 equals 0, and solve for both of those equations. So to solve, I'm going to add 5 to both sides, and I would get x equals 5. To solve for this, I'm going to add 3 to both sides, and I would get x equals 3. So either solution, x equals 5 or x equals 3, is going to be our solutions, because if we plug one of those values for x into our parentheses, if we plug in 5 here, 5 minus 5 is 0. 0 times whatever is in this set of parentheses is going to be equal to 0. So that's one of our solutions. Same goes for 3. If we plug in 3, we would get 3 minus 5 is negative 2, but then here's the important part. 3 minus 3 is 0. 0 times anything equals 0. So these are our two solutions. Same with down here. I think you guys, if you want to try this on your own. So it says solve for x plus 3 times x minus 6 equals 0. So what would be our values of 6 that would work? So if you want to click pause and try this on your own, you're more than welcome to. And then check your work with mine. So what we're going to do is we're going to set up our two equations. So each set of parentheses we would set equal to 0 and then solve. So I would have x plus 3 equals 0 and x minus 6 equals 0. Subtract 3 from both sides, and I get x equals negative 3 for one of my solutions. Over here on the right, we're going to add 6 to both sides to get x equals 6. So these are both of our solutions. There's two solutions, and either x equals negative 3 or x equals 6 would be our zeros or our solutions. I'm going to go to the next slide, so if you need more time, go ahead and click pause. Solve by factoring. So on the previous slide, our equations were already factored. Our equations were already factored. They were in factored form. Where now we have just a quadratic equation. We've got x squared plus 3x minus 10, and we want to solve that. We want to find the zeros. See how it says equal to zeros? So we're trying to find values of x that if we plug into this equation, will make the equation equal to 0. So our first step is, it says solve by factoring, so our first step is we need to factor. So remember how to factor? Doesn't go away. You're going to see this in math classes to come, so good review here. So we remember to factor. We are always looking for factors of our constant term that add up to this b term, or the term that's being the coefficient in front of the x. So I'm looking for factors of negative 10 that add up to a positive 3. So what are those two numbers? I know it's got to be a version of 5 and 2. One of them's got to be positive and one has to be negative because they have to multiply to equal that negative. So which one would be positive and which would be negative? Well, we want it to add up to 3. So if this negative, the 2 would have to be negative. So we've got our factors are going to be 5 and negative 2, because 5 minus 2 is 3. So that makes our factors are going to be x plus 5 and x minus 2. And remember, it's got to be equal to 0. So now, because they have to be equal to 0, I'm just going to set up both equations, or both factored the sets in the parentheses equal to 0, and I would solve for x. So here I'm going to subtract 5 from both sides to solve, and I would get x equals negative 5. There's a negative in there. And then here I'm adding 2 to both sides, and I get x equals positive 2. So those are my two solutions. We can have x equals negative 5, and the other solution is x equals 2. Now let's look at this equation for the second one we've got here. x squared plus 5x equals negative 6. So what do I do here? Remember, we need to have it so that our equation is equal to 0. We needed to find our 0. So we need to set the quadratic equation equal to 0 before we can factor. So how do I do that? How do I get it equal to 0? Well, I need to move this negative 6 to the left side of the equation so that it's set equal to 0. So how do I do that? How do I move that negative 6 to the left side of the equation? Well, I always move terms by doing the opposite of what's being done. So since it's being subtracted, to move it to the left side, I'm going to add it to both sides of my equation. Then my equation is going to be x squared plus 5x minus 6, or I'm sorry, plus 6 equals 0. So see, I didn't add it to the 5x or the x squared because those aren't like terms. So I just moved it to the left side by adding it, opposite of what's being done. Now it's set equal to 0. So now I can find the solutions, because remember, it's always got to be set equal to 0 in order to find the zeros, which are the solution. So now let's go ahead and factor. So I'm looking for factors of 6 that add up to a positive 5. So what are some factors of 6 that would add up to a positive 5? If you said 3 and 2, you are correct, and both are going to be positive this time. So what are our factors? We've got x plus 3, and we've got x plus 2. And we're setting it equal to 0. We're trying to find the solutions, and the solutions are always when our quadratic is equal to 0. And then I'm just setting each of our set of factors equal to 0, and I'm solving for the variable x in each. It's going to subtract 3 from the one on the right to get x equals negative 3. And then I'm going to subtract 2 to solve this one on the right, and I get x equals negative 2. Those are my two solutions. X equals negative 3 and x equals negative 2. So I'm going to go on to the next slide method. One more method to solving quadratic functions, and that's taking the square root. So we know these are quadratic functions because they've got an x squared term. As long as you've got an x squared term, you've got a quadratic function, and it's the highest degree. Remember, the 2 has to be the highest degree. So if you have the highest degree as a 2 for your exponent, that's when you're dealing with a quadratic function. So if you've just got x squared and it equals a number, you can use the square root function, or the square root method, to solve. And what that means is we're trying to solve for x, right? And if x is squared, we want to undo. We want to do the opposite of squaring. And the opposite of squaring is taking the square root. So to undo this square and solve for x, we're going to take the square root. Those are opposites of one another. Squares and square roots are opposites, so they're going to undo one another. Whatever I do to one side, I have to do to the other side. So now on the left, I've undone. I've taken a square root of a square, so I'm left with just a square. And then I need to take the square root of 25. And what do I get? Square root of 25 is 5. So am I done? Is that my only solution? If you said no, you are correct. There's kind of a little something more we need to think about here. When we take the square root of 25, we're looking for two numbers that when we multiply them by themselves, they give us 25. And we know that 5 times 5 is 25. That's one of our square roots of 25 would be 5. Are there another two numbers that when we multiply them by themselves, they will give us a positive 25? Yeah, negative 5 and negative 5. So not only is the square root of 25 5, but it's also going to be negative 5. Negative 5. So whenever we take a square root of a number, we need to keep in mind the positive and negative form that we can have so that we make sure that we're getting all of our possible solutions. Because if we were to plug this back in to our original equation, which was x squared, if we take negative 5 and square it, negative 5 times negative 5 is a positive 25. So we have to keep in mind that when we use this square root method, that we are taking into account that there's going to be both the positive and negative version of our answer. So take a look at number 2. And if you want to try this on your own first, try it on your own. Click pause. And then when you're ready to check your work with mine, go ahead and click play. So we've got x squared equals 36, and we want to solve for x. So we're going to use the square root to do that. We're going to take a square root of both sides so that we undo that square. And when we do that, we get just an x on the left side, and the square root of 36 is 6. But again, remember, we can have the negative version too. So it's going to be 6 or negative 6. What about this last problem? X squared equals negative 9. Well, in order to solve, we would have to take the square root of both sides. Is there a square root of negative 9? Is there a number times itself that would give us negative 9? If we said negative 3, that wouldn't work because a negative 3 times a negative 3 would give us a positive 9. We're looking for a negative 9. And if we did a 3 times 3, we got positive 9. So in this case, there's no way we can get to that negative number. We would need a negative and a positive, and that's not the same exact number that we would multiply times itself. So there is no solution here. No solution because there is not a number times itself that would give us a negative 9. If we graphed that on a coordinate plane, if we were to graph x squared plus 9, because again, we'd have to bring that 9 over in order to graph it, we would find that it never crosses our x-axis. It never crosses our x-axis. It would be like way up here. So it doesn't have any solutions because it doesn't cross the x-axis. So using the square root method only works when you have like x squared equals a number. If you've got an x term, you wouldn't want to use the square root method. The square root method only works when you have an x squared term and a constant term. So note that. It only works when you have a x term. So if you have an x squared term and a constant. If you have a x term, you don't want to use the square root method. So notice there's no x term. It's like not x squared plus 2x or x squared plus 4x. There's no x term, and that's why we were able to use the square root method here. All right, let's keep going here. So let's look at some more examples. So this first one is 2x squared minus 32. Notice there's no x term. There's no x term. So we can use the square root method. So in order to use it, we want to get our x squareds on one side and our constant terms on the other. So I need to move this negative 32. We need to move that to the right side. So in order to use the square root method, I'm going to add 32 to both sides. And now I've got 2x squared equals 32. And now I'm getting closer. Before I use the square root, I need to get the x squared term all by itself. So how do I get the x squared term all by itself? Move this 2. 2 is being multiplied, so I'm going to divide it. I'm going to do the opposite of what's being done. And then I get x squared equals 16. I'm going to move up here. I'm running out of space. X squared equals 16. So before I use the square root, I need to get the x squared term all by itself and the constant term on the other side of the equation, just like all the example problems from that previous slide. So I had to do some algebra. I had to do some rearranging first before I can use my square root sign. I got to get the x term all by itself and then the constant term on the other side of the equation. So I did all the algebra to do that. Let's see. Now I can use the square root. Now I can go ahead and say square root, square root. Do the square root of both sides. Square root of x squared is just x. Square root of 16 is 4 or negative 4. Remember, I'm always going to have both my positive and negative version. All right, are you ready for another example? So now I do have an x term, but look, it's the entire terms that are in our parentheses are squared. So if I were to actually distribute everything out, I would get my x squared term. But we don't need to do that. So to solve, what I'm looking at is that I've got this square right here. It's x plus 4 squared. We need that to go away. We want to solve for x, right? So let's go ahead and just right away use that square root to undo the square. And whatever I do to one side, I have to do to the other side. So in this case, I'm jumping in right away. It's taking the square root to get rid of this square because the square is all by itself. So now the square is gone. I'm left with just x plus 4. And then I'm left with positive or negative 3, right? Because the square root of 9, either I'm going to get a positive 3 or a negative 3. So I'm going to separate this. I'm going to write this equation out twice. I'm going to say, well, either I can have x plus 4 equals positive 3, or I can have x plus 4 equals negative 3. I want to have both my options out there as my positive and negative solution. And then I'm going to solve for either, or for both, not either. I'm going to solve for both equations by subtracting 4 from both sides. And for the first one, I get x equals 3 minus 4 is negative 1. Subtract 4 from my second equation here. And then when I subtract, subtract 4 from negative 3, I get negative 7. So now I've got my two answers. X can equal negative 1 or x can equal negative 7. So again, right away I looked and I saw that square and I was like, let's get rid of that square by taking the square root. Whatever I do to one side, I have to do to the other. And I quickly recognized when I take the square root of 9, I don't just get a positive 3. I get a positive or negative 3, which then I expanded so that I had two equations set to the positive version of 3 and the negative version of 3, and I solved. If you want to try C on your own, go ahead and click pause and try that one on your own. All right, so again, I see that I've got x plus 5 squared equals 16. I've got this square here, and before I can solve for x, I need to get rid of this square. So right away, I think, well, this whole entire, we're squaring this entire quantity, x plus the 5. So let's undo that. Let's take the square root of both sides. When I do that, I get x plus 5 equals the square root of 16. And remember, I can either get a positive 4 or I can get a negative 4 because the square root of 16 is either positive 4 or negative 4. Then I'm going to solve for x in both by subtracting 5 out from both equations. I get negative 1 over here, subtract 5 out, and I get negative 9. So my two solutions would be x equals negative 1 and x equals negative 9. So yet another method to use for solving quadratic functions. But again, we can't use square roots all the time. If you have an x term, it's not going to work. It would be better to use graphing or factoring to solve. And key phrase assignment. So we learned how to solve some quadratic functions by using the square root, and we learned that sometimes there's more solutions than we originally thought to a square root, right? Just like below. What are the possible solutions to the square root of 81? What are your possible solutions to the square root of 81? And that is it for this week. If you have any questions or need any help with anything, let me know.